Over here it is given that a circular region 1 and 2 having current densities J and minus J respectively, such that their region of intersection carries no current. The magnetic field in their region intersection is. So over here we should consider it something like this. Assume that there is a current carrying conductor, cylindrical current carrying conductor, through which some amount of current is moving in upward direction. Let's say the current over here is I, and this current passing through this cylindrical region per unit area is known as nothing but its current density, which is represented by J over here. Got it? So if you are just considering combination of such two cylinders, something like this, they are having different radius R1 and R2. So if you are observing from here, if you are observing it's from the top, so that top view is shown over here. So already we know how to find out the value of this magnetic field inside a conductor by using Ampere's law. So if you are while considering that Ampere's law, we know that first we'll just consider a Amperian loop, something like this. And if you are using that equation, integration of B dot dl is equal to mu 0 times the total current, so you can write over here it is B into let's say if you are finding out at a distance x from here, so it will be 2 pi into x, length of the path, into mu 0 times the value of total current. The current passing through this, that we can take it as current density into area of this part. Area of this portion will be equal to pi x square. So we'll be able to cancel this x and this pi also. So look at the value of this magnetic field at a distance x from this one is mu naught into jx divided by 2. So like that, if you are considering what about the direction of magnetic field due to these two current carrying conductors, so assume that on the first conductor this current is going into the plane. So according to that Ampere's right hand rule, we can observe that the direction of magnetic field lines around this one will be something like this in concentric circles, and in over here it will be in downward direction. Same as like that, if you are just considering in the second cylinder, if current is moving in upward direction, so according to Ampere's law, we can say that the direction of magnetic field lines will be something like this in concentric circles. And if you are observing its direction in between this one, that is also acting in downward direction, so these magnetic field lines will not get cancel each other, they are in the same direction, so they are getting added up. So you can write net magnetic field over here will be equal to sum of magnetic field produced by one plus sum of magnetic field produced by second one. So if you are just considering a point somewhere in between these two current carrying coils at a distance, take it as x1 or x2 from here, so we can write the value of magnetic field will be equal to mu naught into j divided by 2 into x1 for the first one and x2 for second one. So we can write this x1 plus x2, but ultimately we can observe that this x1 plus x2 is nothing but the distance d. So we can write this net magnetic field over here is directly proportional to the value of d.